Hello everyone, welcome to BYJU'S exam prep and welcome with the coffee with concepts. So here I am going to discuss about the entropy, which is the topic of the digital communication in the communication system. So here we will learn with some practical examples that how we actually come up with the formula of entropy. So let me give you one particular sentence. Whether you will be able to read it or not, let me know. So if I give you this particular sentence, then pause it and read it. So if English is your first language, then probably you would be able to answer this what it is written, right? So check this. So have you got this one? So you might have read the same way. Then why you would have you were able to read this particular sentence? This is just because of your mind is super cool, or because there is some other reason. And if it is, then why there is a need of vowels? Because I have replaced all the vowels in this particular sentence, but still you were able to read that particular sentence. So here we come up with the idea that if how many suppose we have the 5 coins and I have the 5 letter word, then which one will have the more information or more entropy? Okay, so this is what we want to conclude here. And for this, the father of information theory, who is nothing, who was Claude Shannon, and he said that measure of information in terms of entropy. The more uncertainty in particular experiment or in particular system, that will have the more entropy. So that is the plot of this. You can see that if some system has more uncertainty, then it will have the more information, right? So let's come up with the few examples, and we will see that which one will have the more information. Like 5 coins will have the more information if you flip those 5 coins, or that particular word jiggy will have the more information. So it depends on that what is the least amount of yes or no question I could ask before I know the state of my system. Suppose I flip a coin and I want to know the answer. If it is a fair coin, then I know that it can be head or tail. So what question I should ask? I should ask only one question, whether is it head or tail. So if I ask the question and I come to know the answer, then I will get the amount of information I gain, knowledge of information I gain from that particular system. So more question I have to ask, more state it could be in. So more uncertainty there is about actually in. So I will show you one example that which will have the more information, and then we come with the second example, which is our six that 5 letter English word.
Both side of the coin if there is a head written. So what does it mean? That after flipping a coin, I will not going to get any information because I have assumed that this is the coin where both side is head. So it is not going to give me any knowledge. So there is no knowledge of gain. So the amount of information will be zero. Now suppose I have a fair coin which has the head and the tail. Okay. So now if I toss it, and before tossing a coin, if I ask that what can be the result of this flip, then there is an uncertainty because it can be head and it can be tail. So if I flip it like this, so what I will get, suppose I am getting tail. So there is some amount of information, and how many times I have asked the question? I have asked the question only once, whether is it head or tail. If I asked the question only once and I came to know that whether it is a tail, then I have got the amount of information. So for each toss of a coin, or each flip of a coin, I need to ask a question once. So in this way, if I toss a coin 5 times, and each time I am asking the question once to get the information, total of 5 times I will ask the question, and hence the amount of information I will get is 5 bit, because there are 5 coins. So the amount of information I am getting from flipping a 5 coins is 5 bits.
So now coming to the second example, that is we know that we have the 26 alphabets and it can be divided into two sections. That is, A to M we have 13 letters, and N to Z we have the 13 alphabets. So we can start with the question that first letter before N. So if the answer is yes, then I can eliminate the all the alphabets which is after which is just after M. So I have eliminated that. We can eliminate the lower half of the alphabet because the answer was yes. So now I have the 13 letter. I have again divided into the two parts. So this is how you can see. Now we can divide it in the half again and ask the question, is it before G? If answer is no, then we will remove the first starting letters because the answer is no. Because if answer is yes, then we would have removed the later half of the section, that partition. So we would have, we will remove this A to G. Now we have H, I, J and K, L, M, and again we will divide it into the two half. So the partition is like this, the three letter and three letter. Again we can ask the question, is it before K? If the answer is yes, then we can remove these three letters K, L, M because the answer is yes. Again, we have the three letters. We can again divide into the two parts. So the question is it before I? So answer is no. So that's why we remove the H. And again, we have I and J. And again, I ask the question, is it before J? So the answer is no. Then again, I remove the I. So what I come up with? I come up with the only first letter of my five-letter word, which was G. So I have come up with the first letter, which is J. So similarly, if I go into like this, and if I look for this particular letter, then I look for the G and G, and then again for Y, then I come up with the, on an average, 4.7 questions will be needed per letter. So in this case, you can see that I have asked the five question for J. Similarly, for to reach to the I, to reach to the G, and to reach to the Y, we will, if sum up, then it will come up with the 4.7 questions per letter. And we have five letters, so 5 into 4.7 is equal to 23.5. So that means 23.5 bits information we have. On the other hand, in the previous case, we have seen that when we flip 5 coins, we got a total information of 5 bits. So from here, we can conclude that the 5-letter word contains more information than the 5 coin flips. So this particular experiments can come up with the single formula which we study in our digital communication, that is information theory, which is known as average information or entropy. So entropy is basically defined as H is equal to summation I equal to 1 to M, probability of any particular symbol log base to 1 upon probability of symbol. So here we have flipped the coin. Okay, so the probability of flipping a coin is 1 by 2. So the probability summation I is equal to 1 to 5 because we have 5 coins. 1 by 2 log base to 1 upon 1 by 2. We have got the 5 bits. Similarly, we have 26 alphabets, and for getting one particular alphabet, the probability will be 1 by 26, and hence we will add them. 1 upon 26 log base to 1 upon 1 by 26, we got the 4.7. So this was the information that we have got from the experiment, and that is by the asking the question if yes or no. So how many questions you ask, according to that you have come up with that particular information, amount of information in that particular system. But that we can sum up with the single formula of entropy, and that is very useful for your any competitive exam like a GATE and ESE. So here is the concept that is coming with the coffee, and we will come up with the more concept in the next lecture. Thank you for watching this, and don't forget to subscribe the channel.